This here is rather a special type of tutorial. I didn't sit down and come up with something I would like to show you, but I was contacted by Professor Andrew Clay McGraw Ph.D. of the University of Richmond. Now, Professor McGraw is studying ethnomusicology, which means he studies music from all sorts of different cultures. And for this, he has recorded lots and lots of interesting data, and he's trying to visualize it in a three-dimensional way. Now, to make it more interesting, he would like to take this data out of the computer and print it in 3D, which brings along some problems. For this, he contacted me and he'd like to help me fix it for him, and at the same time I'm allowed to show it to all of you, so maybe we can all learn a little something. This, what you see right here, is Blender 2.68. And in it is the file as he sent it to me. He sent it to me as a VRML, which I imported in Blender, and this is the result as you see it before. I'll have a look at all of the stuff that's in there, and we'll see if we can clean it up and get it printed in full color. Now, full color is a very special case. There's basically, from all the commercial services, they're using only one color printer. It's made by Z-Core. And the full color print has a bunch of limitations. I have a print here. This is a Sintel from the Open Movie Sintel, and we had it printed in full color. Now, the problem with the material is you cannot print very thin, so everything has to be quite thick. This is because when it comes out of the printer, it is all pretty flexible, so it has to be really strong. It has to be strong enough so that someone can dig into the bucket full of powder and dig out your model without breaking it. So we have to look at that. We have to figure out a way to get the color to the printer in a way that it understands, for which we have to pick a method. But first off, let's have a look at what we've got and see how we can fix it. So we're looking at the imported file. The first thing I always want to do is make sure I'm working at the correct scale. I want to make sure I will print this at the scale that the professor wants and not 10 times larger. I don't want to work in meters or in kilometers. This should be a couple of centimeters long. So we go into the scene settings in Blender and enable metric units. You can use imperial as well, but be aware, most of the 3D printing companies are using the metric system, so it is a lot easier if you start there. I will enable the metric system, and then it defaults to meters. So if I select the biggest item I have here and look at the transform window, it tells me it is 7.574 meters long. Now, that's not useful at all, 7.5 meters. There's no printer that can print that currently. So I will change it to millimeters. I will go 0.001. Everything is scaled 1,000 times smaller. And that means our object is now 7.574 millimeters long. That's quite small. That is half a centimeter. That is really, really tiny. And it's not what the professor wants. He is actually very specific. He told me he wants it to be 7.19 inches long. So I will go into Google and I will type here 7.19 inches in millimeters. And it gives me a result. Google is really nice. They help you this way. It is 182.626 millimeters. So I can close Google again, and I want to know a factor. So how much times do I have to make everything bigger to make it 186 millimeters long? It's a very simple trick to do it. I will hover over the dimension box that I want and paste it with Control V. Control V. It should work. Let me try again. Copy, go into Blender and say, there we go. Now it is 18.263 centimeters long. This is exactly the measurement that Professor McGraw wants. And it's done that, but only in the Z direction for the object that I had selected. And I want to scale everything together so that the entire model is the right size. What I want to know is the scale factor, which we can see at the scale, because it's become 24.112 times bigger than it was to become 18.263 centimeters long. Okay, so I'll take this value, and remember it's 24.112 times bigger. That is what everything has to become. I will undo now. So undo, everything is back where it was. And now select everything we have. Click S on my keyboard to start scaling. Now I can scale until it is the right size. Or you go into your keyboard and you type in what you want. In my case, 24.112. Enter. So it's suddenly become huge, which is great, which is what I want. I have my entire selection, and my entire selection combined along the Z-axis is 18.263 centimeters, which is perfect. I can zoom out. This is my model. It is all the correct size. The only thing that's left to do is to apply this size, because everything is now 24.112 times bigger, but the scaling inside the model isn't. This is a little bit tricky, and I'll show you why it works that way. If I go in and I select a point, so I've selected a point of this model whilst in edit mode, it tells me this point is actually 7.5 millimeters, that sounds familiar, along the Z-axis. Now, it's not 7.5 millimeters because the total model is actually 18.2 centimeters long. It should be a much higher value. That is because this model, as we see it, as a total object, is always multiplied by the scale factor. And if I'm editing, I don't actually want to edit this and have to think, well, if I move it to 8 millimeters, it actually ends up 24.112 times 8 millimeters is the end location. This is complicated and we don't want it. So what we do is we apply the scale to bring this back to 1 by 1, and we can work in the correct scale. I'll select everything again, go Object, Apply, Scale. If I go into this object again, the other one, now this point is at 18.26279 centimeters. This makes a lot more sense. I'm in the object, and what I see as the transform value is what it is in the end model. It doesn't matter for the actual export, but for us working with the model, you really always want to have the scale applied. So if I go into object mode and scale this to make it bigger, you can see the scale value change. If you want to edit a model, you really always want it to be 1 by 1 by 1. That is a lot nicer. Now that this model has been scaled, I'd like to start with a tiny little bit of cleanup. The first thing I notice is there's some things in this file that we don't actually need. So I will have a look around and let's see. There are some dotted lines here. These lines indicate that there is a lamp. We don't need lamps. You cannot 3D print a Blender lamp. It is just used for rendering images. So these lamps, we can see one here, we delete all of them. Also, if I look at this model, you see black lines going all over it. The black lines look like they are something other than this gray horn shape that you want to print. So I will click on them and move the gray horn, and you see there are some black lines floating around. I'll click again, then I've got the black lines selected. I can move them, and apparently they don't have any volume. They are curve objects. We cannot print them. They don't really add anything to the print as far as I can tell, so I will delete them as well. This is a good cleanup to start with. We only have left what we want to have printed, and I think the biggest job is the next one, and that is the gray horn. So let's go have a closer look at that. I'll select the horn and then in View go into local view. Then we can look at only the horn, nothing else is here. We can modify it, and you can do this with the slash on your numpad as well. Go back into global or local view to look at only what you have selected. Now if we look at this horn, I had a look earlier, of course. There is something we need to know. There is a texture type thing on the horn, and it looks kind of odd. If we look around it, it looks like I can look through the ending, but I can see that on the inside of the horn is a texture. This is because the normals are not consistent. There is an inside and an outside to every surface in 3D, and in this case you can only see one side. So in this case we can only see the inside. This is already indicating some issues for me. So what we could do is flip the normals. If I select everything and go into my spacebar menu, just hit the spacebar, and I can flip the normals. Flip them to the outside, and now I can see from the outside nicely what the color is, and on the inside we see nothing. You can look through it. This is nice, it's all consistent, it is all pointing outwards. Next thing is, what kind of color is this? There are actually multiple options. If I look at the mesh data, which we can find here, we see there are no UV maps, so it's not an image assigned to it, but we do have vertex colors. So vertex color it is, which is great because we can use vertex colors for 3D printing. We just have to make sure it's all consistent. We know it's vertex color. Let's have a look at what else we have. It looks actually like a bit of a mess. So what we want to do is check it with the 3D print tools. Now, since I did the Blender for 3D printing DVD, Blender got some 3D print tools added. You may have them, you may not. If you want to make sure, you go into File, then User Preferences, and under Add-ons, you can type in the search bar Print, and if it tells you Mesh 3D Print Toolbox, you have the tools, and if the checkbox behind it is checked, they are enabled. If it's not checked, you can check them now and save your user settings so that it loads again when the next time you open Blender. If it is checked and enabled, you can go in the left to your mesh tools. See, we can close it or click on the little plus, and down to the Mesh 3D Print Tools. Let's do a quick check. I will click check all, and then we wait a few seconds to see what it finds. And in this case, there's a lot of points, so it takes, well, not too long actually. And you see there's lots of stuff. If I make this window a bit bigger, we can clearly see what's wrong. There are 27,872 non-manifold edges. That's a bit of a problem, because you would expect a non-manifold edge is a point that is not in the middle of a face. So for instance, this one here should be manifold because it is connected on all sides. On the outer edge here, it is only connected where the tube is, but not on the outside. So it's an end point. That would be non-manifold. But there are so many. Let's click on it to select them. We can do that in edit mode. And you can see the non-manifold edges are actually in a grid all the way around this shape, which is a little bit of a problem. It has to do with how this shape was generated, and we need to do a bunch of cleanup. This is a bit of a hassle. Now, we could clean up all these points. One of the things we could do is remove the doubles, which merges all the points. So these are 3 points here that are close together. If we merge them, then they become 1 point. That is one way to do it. But we would have to go all over this model to make sure it is completely fixed. This is a lot of work. I think in this case, we're better off redoing part of the model at least. So let's have a look at how we would do that. To make a clean version of this model, I want to look at what it actually is. So I will have a closer look, and if we look from the side, it has a very clear silhouette. This is important, But if I look from the top, the silhouette is actually not that different. The silhouette as seen from here, so it's a tube. It isn't, if I look from the front, see it's perfectly round. It doesn't have a big dent on the right or on the left. It is perfectly circular. This is going to help me. This means that if I make one section, you can see it's made of all these different slices. If I can make one slice completely perfect, then we can just copy it all the way around and we have a really neat model. So I'll copy this one to get started. I'll copy it and move it to the side, and I want to make sure I'm exactly at a certain point. So I'll do 6 centimeters, for instance, to make sure I have a really nice gray line, because what I want to do is I want to have just a vertical line sliced out of this model to start with, so that I have the silhouette as seen from the side. Let's go into edit mode with tab. I can get rid of this for a moment, and we'll have a closer look at what is around that vertical line. Now if I look, this is messy. You can see it's not very precise. There's points everywhere. It's a mess. I don't really want to work with that bit of data. But if I zoom out a little bit and look at this line, for instance, this is really nice and straight, and there's not too much junk floating around it. So I can use that vertical line as my silhouette. I just want to make sure that I can select only those points, and to do that I will rotate everything I have until this line is perfectly vertical. I'll select everything and I want to rotate it around the object center. So to do that, in object mode I will hit Shift S and do cursor to selected. It's the red and white cursor, so that now if I have the pivot point at the 3D cursor, I'm also always rotating around that cursor. So to show you, if I put it here, I'm rotating around the red and white point, or if I put it here, I'm rotating around it there. But if I do Shift S and put the cursor here, I can rotate really neatly around the midpoint. You can see it's perfectly circular. So in edit mode, I'll pick this one, for instance, and I want that to be vertical, which is here. So I'll hit R. I'm just doing it by eye. I think it's that one, right? I'll zoom in, and I don't need perfection, but it should be pretty close. So that's close enough, and you can hit the dot on your numpad to view everything you have selected. So I did that. Now if I very quickly select everything around this midpoint, so I hit B and drag a box, this is what I want to keep, and everything else I want to delete. So you go select inverse, hit delete, and delete all the points. And then we can go in and clean it up a little bit more. Select all the stuff that isn't on the midline. Here we are. And delete all these points. So this looks pretty clean. And if we select everything and look from the side, you can see we have a line really neatly going over the shape of the big horn. And let's have a slightly closer look. We can see points that normally I would remove from a 3D print, like here for instance. There are 3 points in a perfectly straight line, and this one is actually not connected. There's another one there. There's 2 points together here. Ctrl Z to put them back. Why are they there? They shouldn't be there because they're in the middle of a straight line, but if we look in textured view, you can see that is the transition from white to gray. So we do want to keep it there because our colors in this case are vertex colors, and we need points to assign them to. Sadly though, they are not connected. To make sure they're connected, we can select all the points on the line. We're still in edit mode. Go to the tools and remove doubles. So we scroll up to the remove doubles tool, and now if we go in and we select the point at the transition, you see the 2 bits are connected. That makes it really, really neat. At the same time, I'm wondering whether that was clever, because we could have kept them not connected. This all looks really good. We could have kept them unconnected and connected them later. That might have made it easier, but I've done it now, so I'll stick to this. Now we have an outline. Let's make a single slice of our pie. If I look from the front and I count, which I did earlier, so I'm not going to bore you with that, we actually have 32 slices in here. And that means if I make a slice that is 1/32 of 360 degrees, that should be the angle of the slice. In this case, we have a really nice tool. It's called the spin tool. And spin, I've already entered the actual value, rotates around the 3D cursor again, so the red and white one, from the view that you're in. So if I were to do this from this angle, and I say spin, and I can set how many steps I want, so how much detail and how many degrees, and it's rotating around where the red and white point is. Now, I want something really precise. If I look at this model, I'll look at it one more time. I have 32 blocks, so a grey block is 1/32 of a total circle, and each block has sort of 4 slices, right? So there's 1, 2, 3 or 4. Actually, there's 1 line, 2 lines, 3 lines. So yeah, so it's 3 blocks. We go into object mode, select this one, and I will spin it around the cursor. I will actually make 3 blocks, so this is the same as we have in the other model, but I don't want 90 degrees, I want 360 divided by 32, which is 11.25 degrees. I don't even need to do the math myself, because as you see, I can type in here a formula including the divided line, 32, and it does the math for us. This is a really neat first slice. Now we have to go and assign the colors. The type of color we want is vertex color, but before we assign it, I want to have a look at this, because you can see sometimes it is opaque and sometimes it is not. So we can see through some of the faces and some we can't. This is the normals issue again. So we select everything and we say recalculate the normals, and now we can not see through it from the top, but we can from the bottom. It is at least consistent. All the points are aiming in the same direction. Recalculate normals is something you do quite a lot. So if I go into side view now, what I want to do is select all the faces. I go into face select mode, so I can select the entire face at one, that are gray, for instance. So I will go in transparent mode. These should all be gray, and then go back into textured mode, that one as well. And this is a little bit of a job. So with Alt Z and Z you can swap between the two very quickly. So with Alt Z go into textured mode to see what I want, then click Z and B to select what I want. So Z, and I think these, no, a little bit more. So we go in here again and select all of this, and there we go. This is one of the many times that you just need to do the work. There we are. Select all of this. That's too much, you see. And with B, when you're dragging a box, if you're doing it when you're clicking your mouse wheel instead of the mouse button, you can deselect. So select with your mouse button, deselect with your mouse wheel. It's very, very handy. Almost again. I keep getting it just wrong. So we go here. A little bit more. And here we are. Selecting more and more until we have it all. I'm guessing a little bit. Getting better at guessing what should be gray and what shouldn't. Yep, that's right. And here we go. It's nicely gray. I think a little more. That is what I expected it to be. And we're almost at the end. Actually, that is the last bit. So this is all going to have to be gray. So to set it, we want to go into vertex paint mode, which sounds like a mode where you have to paint like manual paint, but you don't have to. You can actually assign a color, which we'll do. I'll go into vertex paint. Then if you scroll to the top, you can set what color you want. For instance, if I make it a red, just drag the dot until it's red. Then go to paint and set vertex colors, or Shift K. It sets it for everything we have. Now we don't want everything we have, but only the faces that are supposed to be gray. To enable that, you can go to this button, Face Selection Masking for Painting. This means you can see what is selected. You will only affect what is selected. So I'll make some green and go Paint, Set Vertex Colors, and only these have become green. This is a really nice way to make all the different colors, but in this case, we want the nice gray. So I'm going to click on this bar here that shows us the color. That pops up a new color selector, which has this one, a nice little pipette that we can take, and we can click on anywhere in our interface. So I'll click on the gray, it's set that color here, and now if we go Paint, Set Vertex Colors, it's assigned the gray. To turn the orange into white, I'll go into Edit Mode, select the inverse. So now we have everything that should be white selected. Go back into Vertex Paint, make it white, or again, use the little pipette and set, did we do it? Pipette, set it to white, Paint, Set Vertex Colors. So this is our first slice. It's really neat. We need to make another slice that's set to exactly the inverse. To do that, I'll go into Object Mode and copy this entire chunk. So Shift D to copy it, rotate it again 11.25 degrees. That's what we had before. Or we can do 360 divided by 32, 11.25 degrees. Go into Edit Mode, and we do the inverse. So now this is white and it's selected. Go to Vertex Paint, and I will select the gray color, Paint, Set Vertex Colors, go into Edit Mode again, select Inverse, then go into Vertex Paint and go, get the white, Paint, Set Vertex Colors. So now we have a double chunk. This is really neat. It's modeled very well. If we go into Object Mode, these two look very clean, much cleaner than this. If we go into Edit Mode, you can see this is very nice, has only quads. Now these two should be merged into one object, which we can do in here. And I'll do that next, actually, which we'll make into one little section where I make the completed horn. At this point, we've finished two sections of the entire cylindrical shape, and I will join them into one. So Object Join. This means in Edit Mode, we can go in here and they are in the same object. They're not actually physically connected, so I can take this and move it, and you can see a gap between them. We will solve that in the end. And I'll make a really quick manual way. I will make the entire circular shape. Actually, I can select everything, copy it with Shift D, then hit R to rotate, and I know the angle, it was 11.25. I have two chunks now, so it should be 11.25 times 2. That means 22.5 degrees around. Now I can keep doing that, so copy what I have selected now, the two slices, and rotate them to 22.5 degrees. That's not very quick. Or I can select everything now, copy it with Shift D, rotate it 45 degrees, because that's 22.5 times 2, so select everything again, copy it, rotate it 90 degrees, select everything, copy it, rotate it 180 degrees. So I didn't use any tools to do everything for me, I just did some really quick math, and in this case everything lines up perfect. So we have a new copy of this thing, and we want to make sure that everything is connected. So all of this, that they are not connected, we select everything and we remove the doubles again. So remove doubles. It removed 4064 verts, and if I select a face at the edge and I move it, you see it is now all connected. This one looks really, really neat to me. So this or this. There are lots and lots of points, and this one looks very, very neat to me. This looks nicely printable because it's all quads, it's all connected. Next, I want to get rid of the old one, which we can discard, and put this one in its place. Now, there is a little bit of an issue, but I can show you a trick for it, because if I look from the front view, you can see that this object that was supplied to me isn't actually at the 000 point. This dot is just floating around at some arbitrary point in space. One of the ways we can do it is we can put the red and white cursor, this thing, exactly where this one is, and then move that to the cursor, but we can do it in a simpler way. I can find the name of this one, so I will give this mesh, go to the triangle with 3 points, I will make this my horn, that's a recognizable enough name, and then go to that one, and instead of shape indexed face set, which is in the object now, I can select the horn. You can see it changed. Actually, we can make this into anything we want without moving the orange dot. So in this case, I'm going to make it the horn, and I'll just delete that one. So we're only left with this, and it's really neat and clean, and it should have no holes in it, no inconsistent normals. But to print it, we have to add another layer. We have to make it solid. Like this cup, in normal day-to-day life, we say it only has an outer wall, but actually this outer wall has a certain thickness. So in 3D modeling, normally what you have to do is you have to model both the outside of the wall and the inside of the wall to see how thick the edge of your cup, in this case it's a tiny little cup, how thick the edge is. So you have to model both the inside and the outside. I don't really want to go and do that manually. Luckily, Blender has some tools that can help us here. What I will do is go into object mode, because I don't want to do this point by point. I want to do it for the entire object. And I'm going to the little wrench symbol, which adds a modifier. A modifier modifies all the points in your object at the same time. So we go to modifiers, and we want to add, and in this case, a solidify modifier. Solidify makes a solid outer edge. As soon as I add it, you will see it is no longer translucent, and it's solid, and it's clearer to see if I am in solid view. It should have an edge on the outside, though at this point it's really, really thin. You see there's an edge here. If I disable it, suddenly it has no thickness. So I enable it, and currently it is set to 10. And I have no idea to 10 what, so let's just click next to it. Apparently 1.01 millimeters. So this outer edge is now 1.01 millimeters thick. That's neat, but for our material, remember we're printing in full color, you need at least 2 millimeters thick to be able to print it. So in this case, we want to save a bit on cost, but I don't want to have a failed print, so I could go and make it 2 millimeters thick precisely. That worries me a little bit, so I will make it 2.2 millimeters. Enter. That's how thick it is, and I want it to have even thickness. If you can see it changes a little bit, makes it a little bit thicker. This is to make sure that inside a fold it is also at least 2.2 millimeters thick. It could fail otherwise to print. So this is nice. Then you only have to choose whether you want the thickness that is added, because it's adding a second layer, to be inside or outside, which is done by the offset. So you can see if we drag this to the right, this is on the outside, +1, or on the inside, and that's what we want in this case, -1. We can go into Alt-Z, textured view again to see it. This is our model, and now if we want to go check it for issues, the best way to do is to apply this modifier, so we make it completely real. In object mode I apply it, then we select everything, go to our 3D print tools. I don't remember whether I mentioned them yet. The 3D print tools were added recently to Blender, actually at the same time that we did the Blender for 3D printing DVD. If you don't have them enabled, here on the left, go to File, User Preferences, Add-ons, and in the search field just type print, and you should be left with Mesh 3D Print Toolbox. It searches live. If the checkbox behind it isn't checked, check it, save your user settings, and you will always have the toolbox available. On the left is the toolbox, and I will just check for all. Takes a little bit of time, shouldn't take too long. You see, it's checked everything. If we scroll down, we get the results. It's giving us some intersecting faces. Well, if I look at the intersecting faces, this looks like a mess. Actually, the tool for intersecting faces currently doesn't work very well. I think it has a problem with the scaling inside Blender, so it doesn't, just ignore them, you know. Then we look at thin faces. Which faces doesn't it like? Well, we can see there's some in here. Well, they, to me, don't look like they're a problem either, so that's probably a little math issue. Sharp edges. We'll look at the sharp edges. Well, they are a little sharp, but sharp edges are actually more of a problem with other types of printers, so we can ignore them here. And overhanging faces, you only need them if you're printing on a extrusion type printer. That's the one that, for instance, did this, that squeezes out plastic as if from a tube, and it builds up from the bottom, and you need to make support. The full color one doesn't need support from underneath because it's built inside a container filled with powder. So we can ignore all of these. This looks really, really good, which brings us to the other big job, which is the little spheres. Now, this is where it might be starting to get a little bit advanced. Let's first go back out of local view so that we can see everything. So we go to global view and we can see all the little spheres again. The global view was not textured, it was solid. That's why it's turned gray. All the color is still there in textured view. And this is great. We kept this and it's fine. We can still see a few spheres on the inside of the tube. They're poking through. Should not be a problem. I'll go into solid view. Next is we want to make sure these little spheres all the way around are printable and are the right type of color. Let's have a quick look at one. I have a nice red one here, or a green. This is a nice blue. And what's instantly obvious is we can see the color in solid view. That's not in textured view. We can go into textured view. Ooh, let's go to textured view, and they retain their color. But we can also see the grid on the horn. We can still see the color in solid view, so the type of color is something different here. And if we look at the data, there are no vertex colors, and that's what we want. The horn now has vertex colors. That is what we're going to use for the entire printable object. We're not going to make it into an image, actually. These guys don't have a UV map or an image. Their color is something else. Their color is a material. So in this case, there is a material that's colored blue, and it's called, that's just the name, shape.236, which is the same name as the object, shape sphere.236. If I select a different one, it has the same color, but it is again a new material. So normally you could do something very quick, like if I want to select all the blue ones, you would say object and then, or select, and you select them linked by material. So everybody with the same material would be selected. So you could select the blue ones, put on a blue vertex color, and you'd be finished. But if I do that here, it doesn't select anything because they all have their own material. That's a pain. You could do this by hand. I could take this ball, go into vertex paint, then go to the color and use a pipette, get some nice blue, then go paint and set vertex colors. So now I have vertex colors, and I can even remove this blue material. That's nice, but we have quite a few spheres. Actually, the total number of objects is 1580 minus the horn, so that's 1579 spheres to do by hand. I don't have that sort of time. So this is where it might get a little bit complicated, because I'm going to dive into Python coding, because it's the only way I know how to do this relatively quickly. Python code may seem a little bit complicated, but let's see if we can make it really simple. This bottom line I'm gonna turn into a Python console. In here we can type Python code and it's executed instantly. Now I will try to do it a little bit quickly to get around the boring stuff. What I can do is find out information about what I have selected by taking the context. That is what is happening in the window above us. So I'll take the context and then the active object. And if I hit enter, it tells me it is shapesphere.240. That's correct. What I have selected is shapesphere.240. Now I want to find out what the color is, so I will go into the active object, then the material slots. I can hit Control Spacebar and it will autocomplete, so if I know if it's something material, Control Spacebar has material slots. I will take the first slot because I know there's only one material. Then I will take the material, and I will take the color, I think. Has no attribute. It is the diffuse color, and it tells me what the color of the currently selected object is. The active object's material slots diffuse color. That is actually what I have entered here, 001, 001. So if I select a red one, or in this case a green one, I hit the arrow up and enter. It tells me RGB, so the green is 1 and this is 0. That is the active color. Let's save that in a variable. So I go up, hit the home key, and I say the color is this. Then I want to go through all the objects and select the ones that have the same color. Because it's such primary colors, that's very easy to do. So I will loop through all the objects in Blender for ob in bpy data objects. This loops through everything. And we do, first I want to make sure, see, if we go through all the objects, not everything has materials, so the Python script will fail. In this case I will try to do the following thing. It doesn't matter if it fails, it just means it's not an object that has a material. So I'll try if the object material slots 0 material diffuse color is double is the same as the color I had, double dot to make it an if statement. I will say select is just one is true, so we will select it if it has the same color, and we have to make sure that there's an except. So if the trying of comparison doesn't work, except we will pass. That means if it doesn't have any material slots, so it fails, it will just pass and go to the next step in our loop. So I'll hit enter and hit enter again, and lo and behold, it instantly selected all of the green spheres, which is done in these 5 lines. Now I want to make it a little bit simpler for myself because I have to type this line by line. I will go into a text editor, make a new text and type it in here, or I can actually can I copy it? I can probably copy it in here. I just want to get rid of all these dots, so get rid of this and one more. Make it neat, and we want to make sure everything is available. So this BPY is a Python module. I'll have to do import BPY, and we go here, enable all these nice things that make it a little bit prettier, and see what went wrong. And I think it probably has to do with indentation in this case. So we'll have a look. In Python script fail, name C is not defined. That is, the C from down here that gives you the bpy.context has been shortened to C, doesn't have it. So we'll do py context active object is materials.0. We'll do it again. So I can select, for instance, a blue sphere, run the script, and it has all of the blue spheres selected. This is very, very, very neat. So we've selected all the blue spheres. I will then join them into one and apply the vertex color. And we just have to do that for every color. We just have to do it once, and that's the next step. We are starting to get close to something like a result. We have all the blue spheres selected. I will go into local view so I can see only what I have selected. And one thing I want to do first is make sure they all have the same material. This is for a strange reason, because I want to remove all of the materials. If I join them now, I can go into object and join. I will do it to show you. I will join them. I make one object, but it has a huge list of materials which I want to remove, and that would take a lot of times of clicking the minus symbol. So I don't want to do that. I want to link, so we can make links, and I want to link the materials. This means that all of these spheres have shape.240 as the material. And if I join them now with Ctrl J, there is only one material to remove. So they're joined, they have one material. I will remove the material and remember that it was blue. Then go to Vertex Paint and set the color to blue. I can do it by sliding, but in this case I want to be precise. I want no green, just 0, 0 and 1. That is great. And then set paint, set vertex color. The blue is now perfect. So go back into object mode and into this view. And we can clearly see this one is now fixed. We have to do this for all the colors. So very quickly, I'll take a red one, run the script, go into local view to make sure, yep, it's all the green ones. Link the material with Ctrl L. So there's one material, Ctrl J to join them, remove material, vertex paint, make it 100% green, none of the others, and paint, set the vertex colors and go out of local view, and we can go back into object mode, select the next color and do it again. So all the red ones, local view, so we can see what we have, link the materials, join into one, remove the material and go into vertex paint, set it as red now, here we go, red, and set the vertex colors. This is going pretty quick. In object mode, select a purple one. Now I'm not sure what the code for purple is. Red is 5, blue is 5. That's nice. So we select them. I can remember that much. Go into local view, link the materials, join into one, remove materials, and in vertex paint I set it up with 0.5, 0.5, and set the vertex colors, go back out. I think only the black is left, so we go, yep, in object mode, thank you. So I can select a black one, run the script, local view, link materials, join into one, remove material, go into vertex paint, color to black, set vertex colors, and we're out of local view. And if we're in object mode, you see nothing is now colored. This is really neat and nice, and it should all be printable. We select everything. We could now join this into one. or we can try and export it as is. Now I don't think there are any more issues, so I want to do a final check before I do an upload. So I'll clean up my view a tiny little bit, make it a little bit bigger, and in this case I'm going to join everything into one object. So select everything, hit Ctrl J. This makes one very big object, but it also means that if I'm in edit mode and I select everything, I can go into the 3D print tools and just run check all, and it checks everything in this one object. Now you might be tempted to take a Boolean modifier, for instance, to try to merge these spheres with the big horn shape, but the 3D print software should be able to handle this type of intersection. The spheres are very clean. The horn, the way that we made it now, is also very clean, so that there's just two shapes, one sticking into the other one halfway. I am not really concerned that that isn't going to be printable. So this is the final check. This might take a little bit of time because it has to basically take 500,000 verts to run this check on. And in the meantime, by the way, I already exported and I'm trying to see if we can import it into a commercial service, which is really exciting. This was actually quite a hard fix, and the way that I showed you is the way that I would do this if it were a commercial job, which actually it is, because the professor hired me to fix his model, and hopefully I can supply him with a model that he can upload and then order himself. Well, we are still waiting for the final result, but I'm not really worried that there's going to be anything. The biggest one I'm looking for is non-manifold points and edges. And look, it's done. So the check is finished. It took a little time. Intersecting faces, like before, don't really matter too much for us. Thin faces, I don't care. Sharp edges are not relevant for this printing method. And overhanging faces are not relevant for this full color printing method either. So all that's left is an export and an upload. In this case, I will go into object mode and file, export as a VRML, which is a good format for using color. You can also use color textures this way, but also vertex colors. So I will use VRML, and yep, I am on my desktop, and I will call it the music export.wrl. Hit enter to confirm that that's the name that I want, and on the left I want to make sure it's only my selection. Well, I don't have any modifiers, so I don't need to apply them. I don't have any texture UVs, I have vertex colors instead, so this one needs to be checked. It should be the vertex color. Z forward, Y up, I don't really care about. The scale we fixed before we went for making it 3D printable, and the path mode is fine. We don't actually have any paths in here. So at this point I can just export and we should be finished. And here we are. It's a little bit later. I went to the shapeways.com website. Shapeways is a commercial service where you can have models printed, not just in plastics, but also in this full color plastic that this model has to be printed in. I've used them quite a lot, and also really useful. I can upload to them. If the model looks good in their viewer, it can probably be printed okay. So it's my final check to make sure I did my job correctly. Looking at the model, it looks pretty good. You see the colors are a little bit more vague, but I think that's their rendering. That's not actually the way it's going to be printed. That's an error, that's okay. The price in full color sandstone, that's what they call the material there, is only 36 euros. That's a little over $40. Shouldn't be a problem. And if I scroll down to check the size, it is 6.669 inches high. They call this the height. It should have been 7.1 inches. That was what Professor McGraw required, but Shapeways doesn't actually take the measurement in a straight axis. They sometimes move the model around a little bit to get an optimum measurement for their printer. So for me, that's close enough. It got through all of their automated checks. I'm sure it could be optimized a little bit further, but I think you should be able to order this print and it should come out okay. I have to say thank you to Andrew Clay McGraw for allowing me to share this with all of you. I hope it's helpful to you, and I hope we can do this again some other time. Thank you very much.